Welcome back to Part 8 on solving trigonometric equations. In this example, we have 1 plus sine of x over cosine x plus cosine x over 1 plus sine x equals 4. We need to solve this equation for x, which is the angle. I'm going to first find a common denominator here, which means that my first fraction needs to be multiplied by 1 plus sine x in the numerator and denominator. And the next fraction needs to be multiplied by cosine of x over cosine of x. Notice that that will give us a cosine x times 1 plus sine x in the denominator. I'll go ahead and rewrite this. 1 plus sine x times 1 plus sine x over cosine x times 1 plus sine x plus cosine of x times cosine of x over 1 plus sine x times cosine of x in the denominator. This is equal to 4. Now if I multiply these two binomials together, 1 plus sine of x squared is 1 plus 2 sine x plus sine squared x plus cosine squared x equals 4 on the right hand side. But now the denominator on the left hand side is going to be cosine x times 1 plus sine x. I'm not going to distribute that cosine yet. I'm not sure if it's going to help me or not, so I'm just going to leave it factored for now. I need to look at my numerator and decide if there's anything I can simplify. Looking for things that are familiar to me for identity purposes, I have sine squared x plus cosine squared x, and I know that's equal to 1, which is very convenient. I'll go ahead and replace that in my next line. 1 plus 2 sine x plus 1 all over cosine x times 1 plus sine x in the denominator equals 4. And now I need to see if there's anything else I can do. I could take a 2 plus 2 sine x in the numerator, and notice that I have a common factor of 2. So I could pull that out front. I'll do that in the next step. All over cosine x times 1 plus sine x equals 4. When I factor out the 2 in the numerator, I'm left with 1 plus sine of x in the numerator all over cosine of x times 1 plus sine of x. That is why I did not distribute that cosine, because I thought that, maybe there was a chance that something would reduce out, and it does. 1 plus sine of x divided by 1 plus sine of x, that's equal to 1, so we'll reduce the fraction. And now I have 2 over cosine of x equals 4. Now I want to clear this fraction, so I'm going to rewrite this as 2 equals 4 times cosine of x, because I'm multiplying both sides of my equation by cosine of x. That reduces my fraction. And now I just need to solve for x by first dividing by 4 on both sides. That gives me cosine of x is equal to 1/2. And I'm just going to rewrite this so we're a little more comfortable with the order. Cosine of x equals 1/2 like this. And then I can find x. X is equal to the cosine inverse of 1/2. If we look at a cosine function, we know that the cosine function starts off at 1 when the angle is 0. Its minimum is at pi, and then it goes back up, and its maximum is at 2 pi. So we have to figure out what the first period of cosine, the angle would be at 1/2, a height of 1/2, and then we will make that true for all periods of cosine, since it repeats. That means I'm looking for where the angle will provide a height of 1/2. And memorizing my unit circle tells me that this will be at pi over 3 and 5 pi over 3. And I know that the angle repeats every period of cosine, and so I can expect that pi over 3 plus 2 pi k will give me every repetition of pi over 3, and 5 pi over 3 will give me, plus 2 pi k, will give me every repetition of the angle 5 pi over 3 that makes this equation true. We'll go ahead and say x is equal to pi over 3 plus 2 pi k, and also x is equal to 5 pi over 3 plus 2 pi k. In this last example, we have 3 tangent squared x minus root 3 tangent of x plus 3 tangent of x minus root 3. Since there are 4 terms in this statement, I'm going to try factor by grouping first and see if it works. In the first 2 terms, I have a tangent of x. And if I factor out the tangent of x, I'll get 3 tangent of x minus root 3. And then if I factor out a 1 in the second grouping, I'll have 3 tangent of x minus root 3. And that does equal 0. I do have a common binomial factor now, and I can factor that out front. 3 tangent of x minus root 3 times what's left over, which is tangent of x plus 1, and that's equal to 0. Now I need to take my binomial factors and set them equal to 0. So I'll have 3 tangent of x minus root 3 equals 0, and also tangent of x plus 1 equals 0. From here, I'll just solve for x, which is my angle, by first adding root 3 to both sides. That gives me 3 tangent of x equals root 3. And then dividing by 3 on both sides gives me tangent of x is equal to root 3 over 3. That means x is equal to the tan inverse of root 3 over 3. Recall that at an angle of pi over 6, we have a terminal point that is root 3 over 2 comma 1/2, and tangent, recall, is equivalent to y over x as a ratio. So we would have 1/2 over root 3 over 2, which would reduce to 1 over root 3, which rationalizes to root 3 over 3. So the angle for which this is true is pi over 6. And then recall that tangent repeats every period of pi, so we would have plus pi k. for all solutions of this binomial factor. Now let's look at the other one. We have tan x plus 1 equals 0, so I'm going to subtract 1 from both sides, and that will give me tan x equals negative 1. That means that x is equal to tan inverse of negative 1, and we happen to know that that will give me a solution of negative pi over 4. And I can then solve this for all the solutions by adding a plus pi k. Notice that if I wanted this to be a positive angle, I could add pi, assuming k is an element of the integers, and that would give me 3 pi over 4. So it's an equivalent statement. You can think about this based on starting in the positive periods of tangent, or you can start about the origin where your tangent function looks kind of like this, where it crosses at 0, 0 on the interval from negative pi over 2 to pi over 2. So we'll stop there.